Hello. Good morning, students. Already in the last week we had seen a program how to write down code in a Xilinx for a OR gate. That part we have finished in the last week. So now we'll just take a next program that is for a 8:1 mux. So again you have to follow the same procedure. First you have to create new project. After that you have to write down the project name. So now here project name written as a multiplexer 81. So there is a location, so it will be saved in a D drive. So next there will be the project setting. So as per we have discussed it, you have to set all the family, device, package, speed. Okay, you have to just select your simulator and your preferred language as a VHDL. Then go to next. Then this window you will get the project and device detail whatever you have selected. Now finish, you will get a next window where you have to select the new source. So in the new source you will get different options where out of that you have to select the VHDL module. Now you have to give the file name. This file name is nothing but your entity name. As you know, your code is divided into three parts, that is a library, entity and the architecture. So here your file name is nothing but your entity name. So you have to follow the rule for the entity name. Your entity name should not start from any number and the special character. You cannot give directly the name as your logical operators, that is and or. So you have to add some numbers there, then you can give the name. Okay, so your entity name is mux81 is given. So next. Now here you are getting the one window where you can declare the input output ports. Okay, so now our circuit is 8:1 mux. So first you have to design, you have to simple draw the block diagram and you have to decide which inputs and output. Suppose I am taking one input as a I, which is your input mode you have to select. Now your I is 8-bit. Okay, so in the there is a MSB and LSB columns are given. So first you have to select the bus, and in the MSB you have to write down 7 and in the LSB you have to write down 0. So your I will become as a 8-bit. So it is 0 to 7 bits will be selected. Now for a multiplexer you require the selection lines. Yes, so by using selection line you can select the particular input. So again selection line is nothing but your input port. Okay, so you have to select the input. Again for 8:1 mux you require 3 selection lines, so that's why you have to select the bus and you have to mention in the MSB and LSB as 2 to 0. That is, it will just give the selection line as 0 to 2. Now there is a Y. Y is your single bit, because for a 8:1 mux there are a 8 input line, 3 selection line and 1 output line. So that's why there is no need to select bus for the Y. Next. So it is again you are getting one summary window where you will get the idea about which inputs output ports you have selected and how many bits you have selected. So here your bus is 7S20 for I, and for S2 S20 input port, and Y is your single bit, that is the out. Okay, now we'll go ahead. Now here you will get a program window. Already we have discussed is by default libraries are available there, that is a library IEEE and there is a package is 1164. So it is by default it is ready. So now you have to go for the entity part. So already your entity code is ready. So you can observe it, your I is in port and now there is a directly standard logic, underscore logic underscore vector. Now we have selected bus. So that's why here you are getting 7 down to 0. Same code you are getting for a S. Now S is your 2 down to 0 and Y is your single bit. So that's why your data type is selected as ST underscore logic, and for the due to the bus there is a vector is selected. Okay, so for a Y simply there is a ST underscore logic, and for I and S due to the bus there is a STD underscore logic underscore vector. Okay, so there is again end entity, so direct entity name, so that's why there is a end multiplexer 81. Okay, so after that you have to go for the architecture part. So in the architecture, there is a blue word you can see, that is your keyword for the Xilinx, but there is a next you have to mention the architecture name. So here your architecture name is behavioral, but you can write down any architecture name here. Okay, so right now we are writing this code by using data flow modeling style. Okay, so whenever if you want, you can change the architecture name. Okay, so there is one select statement is available in the data flow modeling style. That part already Kanetkar madam has covered in the lecture. You know all this, how to write down code by using the select statement. Now by using the selection line, you can select the particular input. Okay, so with S select, after that Y is assigned as I0. Okay, when my code is 0, 0, 0. Okay, then instead of a semicolon you have to put comma, because there is a with S select statement. So it is running parallelly. Okay, if this statement is false, then it will check the other. So that's why instead of semicolon you have to put the column. So next input line I can select is I of 1 when it is 0, 0, 1. Okay, if that statement is false, again I can go with I2 when it is 0, 1, 0, then again comma, then I will go with the next input line, that is I of 3 when, yes, so it is 0, 1, 1, then I of 4, fourth input line I can select when my selection line code is 1, 0, 0. Okay, and when there is any bit you want to represent, always you have to put in a code. Okay, so if you want to give the code as means if you want to represent the code as 0 or 1, you have to use a single code, and more than one bit you have to use a double code. Okay, so that's why I6 input line is selected when my selection line code is 110. Okay, so that's why for all these codes I have put double quote. Now I7 line is selected when others. Okay, now my selection lines, only 3 selection lines are there, then the possibility is from 0 to 7. Okay, so that's why instead of 7 you have to put the others. Okay, so this is my code completed here. At the end you have to write down the end behavioral semicolon. After that you have to save your code. Yes, you have to give the top model as your name here. Okay, then on the left corner you can see the implementation and the simulation. So you can select the simulation here, click on your code, that is mux81. Then in the process window you will get the simulator option. So if you click on the plus sign, you will get the 2 option, that is a behavioral check syntax. Okay, so first you have to check the syntax. So it's running now. So in the below window you will get the message as process behavioral check syntax completed successfully. Okay, then you have to go with the simulation option. So you have to simulate behavioral model. So you have to click on that simulation option. So it's running now. So simulate behavioral model is successfully. So it opens the simulation window. Okay, so already you know in the previous code we had seen. Now in this you have to apply the different inputs for your input. Okay, and then you can observe the waveform for the output. So now in the I7 it is a 8-bit, so it can show as in a bracket 7 is to 0. Okay, so you have to just make a right click and you have to force a value for the I. Now please remember it is 8-bit, so you have to give the data as 1 0 0 0 0 0 1. Okay, and after that you have to apply it and OK. Then you have to apply the code for selection line. Now selection lines are 3. So 0, 0, 0. Okay. So that is your apply OK. So I have selected 0, 0, 0 code and I have given some 8-bit data on I. Now you have to run this code. So after this you will get Y as a 1. Now again we will go back to the code. So now see, when it is 0, 0, 0, my selection line code is 0, I0 line will be selected. So again go in your simulation window. Okay, so there is I0 bit is 1. I0 bit is 1, so that's why on Y section, on Y output line I am getting as a 1. Again we will change the selection line code by selecting force constant. So it is 0, 0, 1. Now just check it in the I1, my output is 0. Yeah, sorry, my input is 0. Yes, so I can run this. So if you move this cursor, so you can see Y is equal to 0. Okay. So according to that, by using the selection line, you can select the particular input here and according to that, you will get the output. Hope students you understood this. Okay. So this is the code for 8:1 mux. So you can try it for a 2:1 mux, 4:1 mux and also you can try it for a 16:1 mux. Okay. So thank you.